Today I'm going to talk to you a bit about Headstock. A lot of you have already been, some of you more times than I have, but for those that haven't, Headstock's an event we put on usually at the end of summer every year. It's sort of like one of our socials, but on steroids. It's a full day into the evening with a variety of different activities. So it's partly as a thanks and a reward for all of our hard work through the whole year from Toby and Craig, and also, yeah, we love to social. And at this one, we have all of us, plus families and friends, and a whole day of fun. So while I'm talking, this is last year's Headstock. It's taken a variety of sort of formats and been in different locations throughout the years, but last year we moved it to Stithians Lake. This meant, alongside the fundamentals of beer, barbecues and music, we also had kayaking, paddleboarding, we had a cinema tent, outdoor laser tag and bouncy castles for the kids. Throughout the whole day, the weather was pretty grim, as you can see from that. But we had Conquering Sounds, who are the reggae DJs who seem to be a regular fixture now at our Headstocks, bringing a few summery vibes, and then different musicians into the evening. Feedback was great. I think I certainly had a great time, and it seems most people did, other than the rain. But the suggestions were, have it earlier in the year to try and have warmer weather, and to give you guys more notice. So, it's going to be on the 30th of June, at Stithians again this year, so we can include all the water sports, but we're also keen to try out some different things. So, if none of the specifics have been decided yet, other than date, location, and we have the whole campsite to ourselves from the Saturday till Sunday. So any suggestions at all for different water activities? We've talked about maybe raft making and having races and competitions. To anything at all. And if any of you are in bands or just like to play music and want to put yourself forward to entertain the crowds, then drop me an email. Also, help is massively appreciated leading up to it and on the day itself. So, obviously, you'll be rewarded with our thanks. But at the end of last year, I also got sent home with a couple of bottles of wine and the biggest block of halloumi you've ever seen. So it was a win. So some things, obviously, are going to be numbers dependent. So in the next week or so, I'll send out a doodle poll just to get a rough idea so we can start planning it. And yeah, if you want to get involved, drop me an email. Does anyone have any questions? No? Everyone's eating, so it's great. Perfect going first. Everyone has their mouth full. So yeah, that's stock.
Using a shared learning environment, and we used Cyber Dojo, which a few of us have used when John came here to do the head talk before. And we focused on effective coding habits and collaborative development. There's other people that also attended that are not here today. You should expect a great presentation from them. You know where you are. So if you want to follow those guys, at John Jagger, at Kevin Henney. So today we'll be our hosts, me and Joe. We're going to talk about 4 things: naming, formatting, refactoring, and testing. Bearing in mind this is a 5-minute-ish presentation. There's going to be more to follow. I'll leave the details for later. First thing, naming. Hungarian notation. Some of you might have heard about it. And it was invented by Charles Simoni at Xerox PARC in the 80s. And later used on Microsoft. And it's a naming convention where it the type of the variable prefixes. The type of the variable prefixes the actual name. So in this case, it doesn't add anything. It's, there's no point putting string or putting int beforehand. And if you have to change something, if, for example, you have an API response and you have string API response, if that changes to a response code 500, 400, not only do you have to change the value, but you also have to change the actual type before, so that would have to be int response, which doesn't make sense. Another thing is to omit needless words. So don't repeat yourself. If you just try to be as succinct as possible to the point, don't beat around the bush. One thing I've come across recently is comments that don't add anything to the actual code. So there was an example that it was in Golang and it said type API response something something, and then the comment above it was API response. That doesn't add anything at all. It's just silly, delete it. Another example in Golang is if you have a package called Redis and you have if you have a file a package called Redis and you have a client, instead of calling it Redis client, you can call it Redis.client. Again, to the point. You don't always see these things when you write in the code, but if you refactor it later on, you'll be very obvious. There's an example here. Convert a class, convert a string, compared to converter.toString. That makes a lot more sense, and it's a lot cleaner, easier to understand and read. Formatting. When in Rome, those the Romans do. Some of you have heard that before. Thanks, Jonathan, for that. That mainly refers to naming conventions, line lengths, file structures. So if you open a file that you've never seen before, a project that you haven't seen before, don't just start adding loads of stuff to it. Take your time. See what the structure is, see what the conventions are. Try to understand it a little bit before you go in, and just adding a lot of crappy code, because it's there, and everybody's going to see it. So if you have a config file, for example, put all your config variables in there. Don't try to put them on the top of the file, because just follow the conventions, what I'm saying. Good example is in Golang, you have GoFMT. There's also other things in different languages in .NET. Let your ID do the hard work. So consistency, that's one of the things that it just allows for greater consistency. So if you open a Golang project, there's many teams here using different projects. Some of them are crossover between different teams. But when you open it, you can see that it's consistent, it's the same everywhere. And what this does is it allows you to focus on writing the code, not spending time formatting it. And one thing that is quite frustrating sometimes is you open a project that's written by someone who doesn't have these tools, you click save and then everything's moved to the right 2 spaces, or it's added spaces, or it's reorganized stuff, and it's just not fun. So make sure you spend some time getting your ID up to scratch with all the plugins that you need, so that it's the same with your team members, so that when you save, there's no big changes, unnecessary changes. And over to Joe.
So a lot of what we're doing on a few days was refactoring, basically, because we were working with CyberJojo, like Filter was saying, with time box around 30 minutes, so nothing was ever actually done. So all of what we're doing was a work in progress, kind of focusing on refactoring things. So if you see from the first bit, it's hard to see what's going on. Yeah, make yourself pretty. Part of refactoring is we do a lot of red-green refactor, so it's the version of the Deming shoe chart cycle. So plan, do, check, act. And we focus on that a lot. And there's some discussion around dead code as well, and what we should do with it. And if it's dead code, it's not being used, it's got no value whatsoever, so there's no point in keeping that code. Similarly to, I think, again, with comments, again, if comments without code, sorry, not comments, comments without code, don't just delete comments. Comments without code is, if it's comments out, there's no point keeping it. We've got version control these days, we should do. So it's just, yeah. Also touched on repetition. If we've got the same thing repeated lots of times, there's usually a possible case to abstract and restructure there to allow that to focusing on dry, so don't repeat yourself. We looked at that quite a lot. Although I have had personal experience of that before, where it's been similar code, not quite repeated, and refactored and created a big complex beast which wasn't needed there. So some similarities are fine, whereas complete repetition often isn't so good. So we were also working through breaking stuff out as well when you're refactoring. So rather than having a large class that's got everything in it and you can't really work out where one thing starts and another thing ends, if you can actually break that down a bit more, so you've got each thing's got its own place, you can then interface with one thing rather than trying to do the whole lot, and you can actually test things in small isolated parts as well. We covered that quite a lot. Which follows on to also, if you've got something really big, it's quite hard to make small changes to it as well. If you're going to make large changes, you're often going to break stuff. The smaller the change, you try and focus on doing small commits often, and then potentially things won't break. Hopefully. And it also ties back to why we try not to do big bang ever as well. That's often all the things all at once. And if you do everything at once, something's going to break, or probably it's not going to be what was wanted at the beginning. And obviously all of that becomes possible with your unit tests, because then you can refactor and change stuff around if it's actually got testing in place as well. And it's never 100%. It's only as good as the tests are, but it's better than no. Testing is better than no testing always. So a lot of what we're focusing on was actually just, like I was saying earlier, was finding time to actually just do things rather than focusing on the done, focusing on actually doing. And also starting again from scratch. I think that was really powerful for me. We were doing CyberJojo sessions, trying to work something out, and then completely throwing it away, starting again. And I think that was really good. And there's also, because we did it in quite a big group, I think it'd be quite nice with chatting amongst ourselves, so people that are at the code retreat, possibly doing a practical for everyone in Headtalks as well, working with CyberJojo, where we all reviewed all of the code that each have done anonymously at the end of it, which is quite good to see. There's so many different variations of different ways of doing the same thing. The actor team as well has also started doing some learning sessions, am I right? With this in place, and I think that'd be quite good if we could do some of this throughout the other teams, of just sort of small presentations within the team and practical sessions on this. So we'd like to continue to do some of that, if anyone would like to do a bit more on what we went through. Someone like to ask any questions?
Why design matters. So I think design is about asking, is there a better way of doing this? It's about making the world we live in a better place, and it's by making interactions with things amazing. Good design makes us happy. Design dictates the way that we interact with something, whether that's physical, intellectually, or emotionally. I mean, everything we touch, everything we come into contact with has been designed. I kind of personally believe that we're all designers. I think whenever we begin a task, we mentally design what we're doing. We think about the tools we're going to use. We think about the order we're going to do things in, and how it's eventually going to look. And I think that's as relevant to coding some new software development as it is to maybe making, a cake. And we all love cake, don't we? I think we can all agree that design is important functionally. This is a very lovely lemon squeezer. But why does it matter that something also looks good? That's also a much more lovely lemon squeezer. It matters that things look good because people make snap decisions based upon an emotional connection visually. Basically, when you look at something initially, you make a valued judgment of its quality based on what it looks like. Obviously, a great example of that is product design. So if you're looking for some free-range, organic kind of sausages, you're going to go for something that's designed lovely and looks nice. If all you care about is how much it costs, then you're going to go for something like this. You might think this is designed on the back of a fag packet, but actually this has been designed exactly to sell what it is. The product designers have done their job, and they've made you buy the product. My partner likes to say, who's in marketing, that you sell the sizzle, not sausage. And whereas I think that is right, I think we'll see, that also it's not just about the impression of quality. So I've lost my way now. But we're not designers here, are we? Most of us are actually developers. So how does design actually affect that? Well, speaking from like a front-end design perspective, it's incredibly important. There are two elements to front-end development. There's a UI and there's a UX. So the UI is the pretty stuff, the sizzle, as it were, But just as important is the UX, which is the user experience. It's how someone interacts with something, how they use it. It's how we make complex kind of issues, make things easy to understand, make them clear and obvious. But I think, I said this from a front-end perspective, it's also important from a back-end perspective or from a coding perspective. If we lay our code out nicely, if we use good comments, structured layouts, reuse components, then things become easy to take over, to understand. We see how they work, and heaven forbid we ever have a bug, we can find a bug very easily. So it's important from that too. I think when you get the visual part right, you've got the sizzle. But I think if you can get the UX price, then basically you've got sausage as well. How do we do it? It's about having kind of a consistent set of user experiences. It's about having components which work in the same way. It's about reusing sort of components and concepts, using a consistency of layouts, of making space, font, color. We impose a very clear hierarchy of order upon something. The end result is that the user is given a really great experience without really knowing why. It just works. It looks beautiful and it works. So consistency, simplicity, order. To sum up, why does design matter? I think it's because design visually and functionally makes people happy. And let's face it, clients are people too, aren't they? Most of them. But I think it's also because good design, visually and functionally, means that people developing products, i.e. us, are proud of them. We're proud of those products, and it makes us happy. So our clients are happy, and we're happy. And if we're happy, and we're proud of what we do, we don't stop that process. We keep proud because we make sure that the development's done in that same way, in a great way, which means happy code. I'm going to finish with kind of one of my favourite examples of design. It's marketing more than design, but it's for IKEA, who's a company who obviously have design at the heart of everything they do. And we all know their slogan, "The wonderful everyday." And I just think that's what design is about. It's about every day being wonderful, but it's about the everyday being wonderful too. So yeah, design matters. Be wonderful.
Okay, so you're all wondering, how come I'm talking about tigers? Apparently tigers isn't a technical subject, so I'm not actually allowed to talk about tigers. So I'm talking about colo. Colocation means customers, servers in our data center. So for this talk, when I say tigers, you have to think servers. When I say zoo, you have to think data center. Okay? Then I won't get in too much trouble. Okay? So tiger, server, zoo, data center. Tigers have cubs, servers go in cabs, which is almost the same thing, so that's quite neat. So let's say I've got a zoo and someone had some little cats and they grew into big tigers and they couldn't look after them anymore. They knew I had a zoo. They said, "Hey, can you look after my tigers in your zoo, please?" I say, "Yep, sure, I've got space in my zoo. I've got an enclosure that's perfect for your tigers." If I had a data center, I would say, "Yes, I've got a room that's perfect for your servers." Or, if they weren't tigers but a small animal, "I've got a cage for your smaller animal." Or I could have a cage for your servers, but you want to keep your servers locked away. So that's all nice and simple. Now, your tigers come along and get put in the enclosure in the zoo. They need food. So part of the deal is I feed your tigers every day. They will have 2 large tins of finest tiger food each day. And I will provide that on a regular basis. Now in a data center, the servers will need power. You don't want to come along with a battery every other day. That will be supplied continuously by me. That's all nice and simple. Good. What else are we going to be concerned about with our tigers? We want to know they're in a good environment, so it's not too hot, it's not too cold, they don't get rained on all the time, that sort of thing. So I will commit to providing a nice environment for the tigers. In the data center, I'll provide a nice environment for the servers. That's not quite strictly true. Nowadays, if you've got a data center, you provide a nice environment for the people who are visiting the servers, and the servers lump it. In general, how that works. Now you're going to worry: are my tigers actually getting the food, the environment that that have been promised to them? In the data center, how much power am I using? Is the environment right? Is the temperature right? Is the humidity right? Are the servers being able to run at peak efficiency? So we'll provide monitoring. You can log in and you can see how much power you're using. You can log in and you can see that the tiger's being fed every day. You can see what the temperature was in their enclosure. You can see what the temperature was in the data center. So everyone's happy with that. Now, you've got tigers in a zoo, but I want to be able to visit my tigers. You can't just have people wandering in and out of a zoo. You have kids going into the enclosures and getting eaten by the tigers. It would just cause hassle. You don't want that. So you will have some kind of arrangement to allow people in. Data center is similar. You can't just have people wandering in off the street. You will need access controls. You'll need some way of booking in to say you're going to visit, that kind of thing. So you'll make access requests, and if you've made an access request, turn up at the door to let you in. What else? Maybe you want some stuff delivered for your tigers, some new play equipment. They've eaten all the old play equipment. So you say, right, DPD are going to be coming along on Friday and they're going to deliver some play equipment. Is that okay? And I say, yeah, that's fine. If it's a data center, I'm going to have a new server delivered. That's fine. We'll let them deliver it on Friday. Okay, so now we've got the Tiger's play equipment. It's been delivered and it's sitting there. I want it put in the enclosure, please. Can I have some remote hands? Can I have some zoo employees go and put it in the Tiger enclosure, please? Yep, we can do that. That's a remote hands request. We'll do it. Similarly for data center, I need someone to go along to my server in my room and turn it off and on again. I can do that. That's a remote hands request. And that basically is Colo. You're all now Colo experts, so when the Colo team needs more stuff, you're all able. Excellent. So that's Tigers.
So good thing we had a talk about tigers and another about design, because they were not technical, so you're not sleepy, and now I can put you all to sleep with my board. I'll get you all bored. So I am the iOS man, previously known as Flavio Silverio, and this is a very brief introduction to functional programming, which I called Functional Programming 101, like from the American system of 101 introduction. Here we go. Yeah. So a brief overview of it. It's a programming paradigm, so just like object-oriented programming or any other paradigm, it's just, but this one is heavily based on math, so it's very mathematical. And the functions are first-class values, so everything is a function. This means that the function can be an argument or can just be data. Everything is a function. I'll say functions a lot on this presentation because it's functional programming. There's a lot of higher order functions, which is just a very fancy name for functions that either accept other functions as arguments or that return functions as a result of their functioning. So some of the essential keywords that you'll read if you start looking for functional programming will be immutability, one of them. And then higher order functions, again, like I said, it's very important, and everything's a function. And pure functions. Oh, look, functions again. I'll have a brief overview of pure functions and currying. I was actually planning on
doing also about immutability and higher order functions, but time was of the essence, and I have 5 minutes, and they'll kick me out if I take like 15. So, and you'll also read about monads and gonads, but those I'm not touching because they're very sensitive. So, and functors, but that's a place I'm not going in, definitely not. So let's start with not immutability and not higher order functions, but with pure functions. Who here knows what a pure function is? Great, 2 people, 3. Okay, so you cannot reply to my question next. So a pure function is a function that has pure in its name. No, it's not. So here we have 2 functions. One is operation x that will receive an a and b, and then will multiply a by a random number plus b, and then you have operation y, which is receives a and b and just returns a times b. So if you had to say that a is a pure function, even if you don't know what it is, who would say that a is a pure function? Hands up. No? 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 The public doesn't want to? No? Cooperate. And what about operation y? Would anyone say it's a pure function? Oh, you guys are smart. It's not fun like that, because I could say that the people who chose Y was wrong, A was wrong, but nobody did. So you're all correct. Yay. That is because a pure function must have outputs that depend only on the inputs. So on the case of A, since it's generating a random number and adding B to it, even if we use the same inputs, we don't know the output. So it's not predictable. And it's not a pure function. It's an impure function, and this is very important on functional programming, because pure functions are one of the bases of it. Another example is now using Python, just to show that I know a lot of programming languages. We have a global variable on the first one, and then we have a function that receives an argument and adds it to the global variable, and that's an impure function. And this is another function that just does the same thing, but it also receives the list as an argument, and this is pure, because any function that affects any state other than the state of the inputs or outputs is a non-pure function. So, yeah, since that's using a global variable, so it's out of its scope, and yeah, it shouldn't be affecting any state, like it says. So, yeah, these were pure functions, and now let's go to currying. Yeah, I know it's a nice name. When you hear that name, you think about something exotic, something flavorful. Yeah, we're all thinking curry. And as much as I like curry, because I do, as much as probably most of us, it's not as good as a curry. It's basically dividing a function that has several arguments into, it's dividing a function of n arguments into n functions of one argument. So in this case, I have a function that would receive an a and b and would return an int, which should be the sum of a and b. I would call it just like usual, 2, 3, and then I would have to, for have that curried, not masala curried, but still curried, I would have to receive one argument and then return another function that still receives an argument and returns the sum of both. So here I'm just calling 2 functions. We can see that as a pipe when using the command line, basically, that one function sends to the other. And yeah, that would be currying a function. Yeah, it's very simple, I know. You well understood what it is. And just now, by using JavaScript again to see that, yeah, I'm a programming languages guy. So, no, I'm not. We have a function here that would receive 2 strings and would just print the 2 strings, like here. I would just do a greet. I would call, yeah, that's wrong because it should be greeter, but greet hello at talks, it would just print hello at talks. And to curry this comes the simple part, which is we would have, okay, yeah. I know it does, but I'm trying to, yeah. So we have a function that will return another function that receives an argument. Okay, I didn't think this through. Okay, so we can create a function that's like the inner function there, that is a partial implementation of the whole function. In that case, it recall that we will always need the two arguments, and they would be pretty much connected. And here, since we do have a function, an inner function that's returned when you create that one, you can have like the partial implementation of it. So in the first example, you just have the I there, and then you can, by calling it with the second one, you can have like either people from PIC, either people from OP, and this will be a curried version of the first one. Yeah. You can also call them like, again, like pipes on the command line, and there I have, with help from my Japanese friends, and it should say Konnichiwa Flavius-san. I hope they didn't reply to me, but I don't see any person who understands Japanese laughing, so it should be Konnichiwa. And oh, there's no graph. Where's my graph? This is okay. This is a very nice graph that it was absolutely meaningless, but it had two different colors because everyone loves graphs. So yeah, but it only has one color. It's black. But it should have like a white blue and then a dark blue, and it's meaningless. It's very simple because the question of the graph would be, did you like the curry explanation? The currying explanation, and I did ask for a few imaginary people, and they all said that it was very simple. So, but yeah, unfortunately, there's no graph, and we all love graphs. So, we're done. Yay.